Hello YouTube viewers, welcome to my show Science Thursday. In today's episode we're going to take a look at biogas power plant. So let's dive right into it. First you have to understand, whenever you have anaerobic digestion of organic material, you get this output. So basically what does anaerobic means? Lack of oxygen. Now this can happen anywhere, any place. Basically if you have a lot of thing that is trying to digest, and let's say on top of the layer, whatever pile you have on top of layer, it's getting oxygen, but what is down below is not getting, it will do what's called anaerobic reaction. In that sort of scenario, some gases come out. Same way like we breathe oxygen and give out carbon dioxide, this also does the same thing. However, due to the lack of oxygen, what they give out is methane. So whenever somebody says biogas, be mindful, it's a mixture of gas. It's not that there is only one thing in it. It is a mixture. So mixture generally, mostly 40 to 75% of the content is methane. Then it has CO2. Then it has some part H2S, basically dangerous thing. And it's carbon neutral. So what does carbon neutral mean here is same as biomass power plant, on which you can check my video, is that if you burn this, if you burn biogas, the amount of CO2 released into the atmosphere would be captured back by the living matter. So it's a complete continuous cycle. So you don't have to worry about polluting the environment. You are giving carbon dioxide to the atmosphere, yes, but it will be taken out of it. So you don't have to worry anything about it. And as you can see, like a cow is gonna give it out anyway, one way or the another. So you may come to the question why there is so much interest into this. First, it's very easy and simple. Now, what does that mean, easy and simple? Think of it this way: whenever you see power plants, you imagine something big like this, like, big industrial, but it can be as small as this. Like, I'm talking very small. Like, this is super easy. This technology we've known for like roughly 1950s and 1970s. Like, I'm talking in India, we were using this in 1980s. And I mean, large scale rural areas were using this. So suffice to say, it's super easy, super simple, nothing fancy about it. You can use this to get your energy. And I don't mean electricity. Many times you also can use this for cooking fuel, as in like using LPG. Instead of using LPG, you can use biogas. So in that regard, we've been using this for very, very long time. So suffice to say, in terms of green energy, we know this, we nailed this out. Second, the waste that comes out of it is a biofertilizer. Now this is the crucial difference between biomass power plant versus biogas power plant. If you have a biomass power plant, it's burning it, so basically all you are getting at the other end is ash. When you do this, you get biofertilizer, basically one of the best type of fertilizer. Basically you can make sure, if you dump biofertilizer properly, it's not like, you close your eye and throw whatever you want. It's like, if you do it properly, you can retain soil's fertility forever. Literally, this is a continuous cycle. You can literally grow crops, people consume the crop, or animals consume the crop, and then they give you out cow dung or anything like that, bullshit basically, and then you convert that bullshit into energy. You take the energy out, you put the biofertilizer back into the soil. It's a complete cycle. This is the most attractive aspect of it. Now many of you know, like in recent year, because we started to use fertilizer too much, we started to erode soil, basically damage the soil, because we were putting one element too much. It was unbalancing the pH level, it was unbalancing the basically bioorganics into the soil was getting compromised. This bypasses all of that. So this is the crucial. You are not only getting electricity or energy, you are also getting fertilizer as a waste product. So this is awesome. Second, the scale size for this sort of plant is very awesome. Basically, many of you must have heard, like if you want to make a coal fire power plant, it's not feasible to make it very small, as in like 1 megawatt or 2 megawatt. You can make it, it's not going to be efficient. Here, however, it can be very small. I'm talking something very small versus something very big. Like this will only provide, let's say, cooking fuel for one day for one small family. This will provide either cooking gas or electricity for a small city. So suffice to say, scale wise, this can go in very large varieties. So how does it actually work? Where is this magic is happening? Basically, all you have to understand is that microorganism, you are not doing anything. Microorganism is transforming the bio waste, whatever it is, human feces or bullshit, It's converting that into a biogas. Basically, you are letting these things rot in the absence of oxygen. That is the crucial aspect. It must be airtight, it must be sealed. Basically, there should not be any source of oxygen to it. That's why you see carbon dioxide coming out of it, because no matter how perfectly you seal it, whenever you are feeding it in, there is some amount of oxygen there also. So it does convert into CO2. So if you can remove oxygen going in, awesome. And you have to make sure that this whole digestion process, because microorganisms generally like warm temperature, you generally target around 30 to 36 degrees Celsius. So, and second, this is crucial aspect. So you put your thing from inlet, you put it into what's called digester. Basically, it's nothing, it's just a pit where you can let it rot properly, and you make sure it's sealed. This is crucial. It must be sealed. If there is even an air leak, oxygen is gonna seep in and then it's gonna ruin your plantation. So once you seal it up, this decomposes, gives out methane. Then because of pressure that is being built up here, is gonna push it down. So pushing down, it goes to the second output tank where you can collect your fertilizer. Now be mindful, you have to make sure this is properly sealed. If oxygen leaks into it, even by little, it will reduce your methane output. So for that reason, we generally either bury it down or seal it with water. We have to make sure this is properly sealed. However, not everything is dandy with this. One side effect of this plant is that it also creates what's called H2S. Now that's problematic because it can cause it's not only a toxic sort of stuff, it can damage machinery. Now generally, if you have a good biodigester plant, it's not going to produce 10% of it. It's only going to produce like 0.1%. But suffice to say, it must be scrubbed out. This is crucial. You must remove it from your if you are directly using it as cooking fuel, you don't have to worry about anything. But if you want to use it in a generator, you should remove it out. So we generally clean these gases with what's called biogas scrubbers. You can buy them on Amazon or Alibaba if you want. So that is the crucial aspect. You must remove H2S that comes out of it. So is there a con to this? Well, yes. The biggest con of this structure is what's called scattered sources. There are so many sources of biogas. Now you might think that's a good thing. Well, yes and no. The reason why I'm saying it's not a good thing is simply because imagine landfill. Yeah, things that are biodegradable in landfill are also producing methane. How are you going to collect it there? Dairy farms like milk farms or cow farms, basically they have insane amount of biomaterial. Of course, many of them nowadays have their own biogas power plant, but that's the second source. Third source is whenever you have human. Basically, we also produce feces. Basically, that is a source of biogas. That's why many of you who have septic tanks, rather than directly connecting to sewage, you must see there is a chimney sort of structure built to the tank to make sure the methane leaks out. Now, of course, if you light a lighter there, it's not going to catch fire because it's not designed so it only produces methane. It's like there will be a percentage of methane, but not 100% methane. So suffice to say, like let's say you see a colony or you see a hostel or you see a PG where 100 people are living or 1,000 people are living, there is a lot of potential there. But how many places you gonna build the biogas power plant? Basically, you need to build it everywhere. So that is a crucial aspect. This cannot be like in some scenario it does make sense to make one big centralized plant. In other scenario it does make sense to have multiple small units. So let's say you have a village where a lot of milk farms are there or a lot of cow factories are there. So in those sort of scenario, it's efficient for you to ask all of them is, hey, like just give us your bullshit basically, and we're gonna convert it into electricity, because if you build a larger plant you can increase the efficiency. So this sort of situation cause a problem for implementing this on a large scale. Either you create a lot of small one which loses efficiency, or you create big ones and then figure out how you're gonna collect things. So that is a kind of tricky issue with this. Second, it needs scrubbers. Those scrubbers are not super cheap. So suffice to say, we generally let the biogas go through steel wool, and it removes the H2S. So suffice to say, that is a kind of tricky, but not impossible. It's tricky, but it's not impossible. Now, this is the part that really hurts it. That is not very powerful. So this is a biogas plant, and as you can see, all it can do is cook a small pot of water. So if you're expecting this to run your country, it can't do that. Like it can provide significant amount of power. Germany has been leading the way, and they can get roughly 10 to 20 megawatts of power out of it. But suffice to say, 10 20 megawatt for a country, it's almost nothing. So for that reason, this is the limiting factor of it. Now, it can be helped if you start collecting biogas from everywhere where it's being created, because methane makes CO2 like a child throwing tantrum. So people say CO2 is causing greenhouse gas. Methane is like, bro, I'm here. Like, when methane starts causing greenhouse effect, it causes a runaway effect. Basically, 1 kg will release 10 more kg, 10 more kg will release 50 more kg. It's like it's gonna roast your planet and turn Earth into Venus. So suffice to say, methane is very, very, very dangerous. We have to make sure we burn every single bit of methane before it reaches the atmosphere. So suffice to say, we have to use it. We have to do it. And the biogas manure that comes out of it must be handled carefully. Not that it is dangerous, not that it's toxin. It's just that if you are dumping it into a fertile land, you must check the soil content. You must check it. Does it need it? Does it, like, your biogas? Because many of you know who have been dealing with plant life, that plant life is very choosy in its diet. So if you put too much nitrogen, you can harm the plant. You put too much something that changes the soil pH level, you can harm the plant. So you have to be mindful. It's not just, oh, it's fertilizer and just throw it in every crop. So you have to be a bit mindful. Not difficult, but you have to be mindful. So what we can expect in the future. Now, first is, whenever you have large human complex, this is the most untapped area for this. Imagine a community building or large scale buildings where you see hundreds of families living there. There is a lot of potential of energy there. How much, you may ask? Well, think of it this way. Like, let's say there is 100 people living there. You collect the biogas for 1 month. So next day, you can literally run your entire complex on biogas directly. Now, that may not sound much, but ask anyone who is paying the electricity bill for a complex that has 100 living people into that. So suffice to say, 1 day, and imagine that means roughly 12 days, or if it's a properly well-built, implemented plant where you make sure the biodigester is always at 36 degrees Celsius, you are scrubbing the methane that is coming out of it. If you are doing it properly, you can get upwards of, like, for around 11 months of biogas, you can get upwards of 1 month of electricity. So suffice to say, it's awesome. And not to mention, you can sell the fertilizer, so it's double benefit. It's not only that you are taking care of your garbage, not only that you are getting electricity out of it, you are also preventing the degradation of atmosphere. So suffice to say, in all front is awesome. It must be done. Like, it has to be done. So if you see any large scale complex building where you have access to its owner, try to convince of them like that, because there are some companies that are directly trying to implement this sort of structure, because human feces does require a bit of different temperature and water mix, so it does need a bit of engineering. Not complex, it's just somebody has to control the valve, basically computers. So suffice to say, and you can make something very small. As you can see, these are people for scale. It's almost the size of a human, like this big, and it can provide enough biogas for 1 cooking session. So let's say you dump all your waste, and in this scenario, the waste dumped here was only kitchen waste, not human feces. So doing that, only kitchen waste, like everybody is just dumping the kitchen waste here, they got upwards of like, let's say 1 week's kitchen waste give you 1 day of cooking gas. So over time, you can save a lot of money, and you are also taking care of your waste. You are also preventing the atmosphere, and not to mention, this exit pipe gives you fertilizer. So suffice to say, there is no point of loss in this. It must be done. It is crucial for our atmosphere, and we have a free source of energy. Now, localized plant make much more sense in this, because the more I researched this sort of situation, the more it turned out, because there are so many sources for this, it's ideally useful if you start making a lot of small sources. Like, if you have some scenario, let's say you have a scenario where there is a village that produces a lot of agricultural waste, yeah, then make a centralized plant, because then you can actually subsidize the aspect that you have to go and collect it. So localized plant, like as I already mentioned, like imagine a large human complex, basically large colony building. There are a lot of people there, and even if you can save electricity for 1 whole day, that's a lot of money that you will save. And not to mention, you're getting that from your garbage, you're getting that from your shit. So suffice to say, it's free. And the next big thing is fuel cell. Now, many of you know that biogas can be directly put into any engine. Specifically, petrol engines are very easy to convert, and there are some conversions that you have to do on normal engines so it can run on biogas, but they can only give you 20% efficiency. Now, fuel cell on the other hand, like this fuel cell, Ceres Power, known as steel cell. Basically, you can type, I have provided link in the down below, and this cell can give you 50% efficiency. So suffice to say, whatever energy you are getting, you can get a lot more energy here, 20% more here, 20 or 30% more. And not to mention, this also gives out usable heat. So heat also, let's say you live in a place where it's very cold, you can use the heat. You live in a place where it's not that cold, you actually want a cooling solution, you can run that heat through what's called absorption chiller, and you get cooling out of that. So suffice to say, fuel cell can really improve the performance of all biogas plants that already exist. So there is a lot of room of improvement in this sort of situation, and it can be done everywhere, from Africa to India to China to America to Australia to Germany. So this was my presentation on biogas. I hope you liked it or learned from it. In that case, please give a like and share it amongst your friends. And I would urge you to leave a comment what you want to see in the next episode of Science Thursday. And if you disliked it, you can also dislike it. I would urge you to subscribe and press the bell icon if you are free. And as always, thanks for watching.